In this problem, we have this cantilever beam, and it is subjected to these external loadings. Over here, it is supported by a fixed support. And we need to determine the internal normal force, shear force, and bending moment at point A, which is immediately to the right of the 6 kilonewton-meter applied couple moment. So for this problem, first of all, we need to determine if we need to solve for any support reactions. Because if we are going to section this beam at point A and choose the right-hand side to do our analysis, then we do not have any support reaction on the right-hand side. Therefore, for that reason, we are not going to solve for the support reactions at this fixed support. And just like I said, we're going to section it at point A, and we're going to draw the free body diagram of the right segment. So free body diagram of right segment for our analysis. So this total length right here is going to be 4 meter plus 1 meter minus another meter. So overall, that's going to be 4 meters. And this is point A. Because point A is to the right of the 6 kilonewton meter applied couple moment, we do not need to include the 6 kilonewton meter couple moment on our free body diagram of the right segment. So what about the other forces? We have this distributed load from here to here. And we also have another concentrated force here. So for this distributed load, we can replace it by a concentrated force right here. The magnitude will be 0.8 multiplied by 1.5, and that equals to 1.2 kilonewton. This distance right here is 0.75 meter, half of the 1.5 meter. Therefore, from point A, that's going to be 1.75 meter. So with that said, we're going to, on our free body diagram, directly mark it as the 1.2 kilonewton force with a location 1.75 meter away from point A. So far, I have included all the external loadings on the right segment. At point A, we have our unknown internal reactions. So I draw them always according to the positive sign convention. Therefore, the normal force is to this direction because that's tension. The shear force is in this direction because this shear force is creating the clockwise rotational tendency for the right segment. And also bending moment is creating upward bending tendency. So now I have completed my free body diagram, and we're going to write our 3 equations. Basically, we're treating this as a rigid body equilibrium problem and try to solve for our 3 unknowns. So our coordinate system, I'm still choosing my x and y coordinate system like this. Notice that the direction of the positive or negative signs of the direction according to the xy coordinate system is still as before. Therefore, when I summarize the force along the x direction, still I'm considering right to be positive. Therefore, my normal force is actually negative. So the normal force was drawn according to the sign convention for internal reaction. But when we are adding the forces up according to the sign of the chosen coordinate system, you still have to follow that. Therefore, normal force is negative. And then we have the x component of this 4 kilonewton, and that is negative 4 times cosine 30 degree equals to 0. Resultant force along the y direction, up is positive y. Therefore, we have VA that is positive, minus 1.2 minus the 4 kilonewton force also has a vertical down component, and that equals to 0. And lastly, resultant moment about point A. We always write the resultant moment about where we section the member, because this way the unknown VA, the shear force, does not create moment about point A. And again, still following the sign convention, counterclockwise is positive. Therefore, this MA right here is our unknown bending moment. It is clockwise, therefore it's negative MA. Shear force VA does not create any moment about point A. 1.2 kilonewton creates clockwise, so negative 1.2 multiplied by moment arm 1.75. And for the 4 kilonewton force, the vertical component creates clockwise rotation about point A. The distance is from here to here, and that is going to be 4 meter minus 1 meter, therefore 3 meter. Therefore, here we have minus clockwise 4 times sine 30 degree, and the moment arm is 3 meter, and that equals to 0. So now 3 equations, 3 unknowns. We can solve for all of them. NA equals to negative 3.46 kilonewton. VA equals to 3.2 kilonewton. And lastly, the bending moment MA equals to negative 8.1 kilonewton meter. And let's solve this problem.